I modified this drawing just to illustrate the way we've been teaching it. The A value that you see here and here represents the represents the horizontal distance. If the ellipse is horizontal, it's the distance from the center to the vertex. If the ellipse is vertical, it's the distance from the center to the co-vertex. The B value represents the vertical distance from the center to either the co-vertices or the co-vertex or the vertex. If the ellipse is horizontal, B is the distance from the center to the co-vertex that you see here. And if the ellipse is vertical, it's the distance from the center to the vertex, like the one here on the right. The next value that you need is to calculate C. And C, when you're dealing with an ellipse, C is represented by the formula C squared equals A squared minus B squared. So as long as you know any two of those, either A and B or A and C or B and C, then you can calculate the others. The other chart here is from the foldable that, had we been at school, we would have created. And I've drawn the lines because it's a little bit out of alignment here. But the formula for the vertices, if the one on the left is a horizontal ellipse, and the one on the right is a vertical ellipse. So looking at the one on the left, the formula for the vertices is H plus or minus the value of A, comma K. If it's a vertical ellipse, the vertices are at the points H, comma K, plus or minus B. So again, plus or minus the distance to the vertex on the left, plus or minus the distance to the co-vertices on the right. So, given your problem, given the information that you have, we can determine the values of H and K and A and B so that you can write the equation. So, a graph. We have foci at negative 30, 19. So, we'll put focus here. Negative 30, 19. And negative 10, 19. Negative 10, 19. So, if our two foci are horizontal, then it's going to be on a horizontal ellipse. So we can find the center by finding the point halfway between those two. So if this is negative 30 and this is negative 10, so then we would find our center, which is halfway between these two, at negative 20, comma 19. This would be our center, which is our HK. Now we need to find the A and B values. So we look at from the diagram above, we know that this distance between the center and the focus is C. You are also given the vertices at negative 32, negative 32, 19, and negative 8, 19. And these are the vertices. We know that the distance between the center and the vertex, this distance is A, because it's a horizontal ellipse, so the distance between the center and the vertex is A. On a vertical ellipse, the distance between the center and the co-vertex is A, because we use A for horizontal always and B for vertical always. So the rest is just based on calculations, so that we know that from negative 20 to negative 8, that distance is 12. So A is 12. We know that C is the distance between the center at negative 20 and the foci, or one of the foci is from negative 20 to negative 10, so we know that C is 10. And from our formula that we're given above, we know that 10 squared is equal to 12 squared minus B squared. 10. Having done the calculations for A squared and B squared based on the distances where A is equal to 12 and C was equal to 10, then we find that B squared is equal to 44. We don't need to calculate the square root because the formula, if we go back up and look at the formula includes A and B in terms of A squared and B squared. So we knew that A squared is 144. We found that B squared was 44. And we found that our center H comma K was at negative 20 comma 19. So then we plug in those values, and we knew it was a horizontal ellipse. So we get x plus 20 squared over 144 plus y minus 19 squared over 44 is equal to 1.